Exciting new research is starting to shine a light on how the waxing and waning of the Asian summer monsoon impacted lakes and wetlands in Southeast Asia, and how these shifts are linked to global climate patterns. Over the last 5 years, a team which started with a small group of scientists from Stockholm University, the University of Nebraska, and from Chulalongkorn University in Bangkok has been taking samples from lakes in Thailand. There are now over 20 scientists working on the project from 8 universities around the world, and the number is growing all the time. The cores of sediments dating back 50,000 years have come here to Sweden to be processed.
Basically, we've been gathering data on one primary lake and some of the other lakes that we've worked on, and combine those data with some material that other people have worked on, other published records, to try to better understand how Thailand fits into the whole Asian monsoon system.
I was in a high school, for example, in Bangkok in spring, and presented the research project to the students, and the students thought that was really fascinating to learn more about how these lakes and wetlands have developed and what kind of environmental history is hidden in the sediments of these wetlands.
Once they've arrived, the cores are kept in cold storage until the team is ready to start the painstaking process of analysis.
We take the cores out from the cold room, then we clean the core surface very carefully, and we describe the cores, we correlate them, and the next step would be that we do these non-destructive XRF measurements. So the beam in the machine measures along the core what kind of elements there are and how they are distributed along the whole core. Then we come to the next step, and we usually start with a very simple analytical method, which is loss on ignition. The difference in weight between the dry sample and the burnt sample can give you an estimate on how much organic matter there is in the specific sample.
They also sample for biomarkers, which indicate the types of plants present at a certain time in the past, and help paint a more thorough picture of what the climate looked like.
Basically, what I have to do now in my lab is to grind the samples which have been freeze-dried into finer components.
From there we will look at specific molecules that are now dissolved. We will separate those out, and we will target individual molecules that we know are from certain types of algae, or we know are from certain types of plants.
They're basically trying to assemble a giant jigsaw puzzle, which will show the lake environment and also the terrestrial environment at certain times in the past. Much of the sampled material is analysed in Stockholm, but some is sent to colleagues across the world. For dating purposes, they come here to Belfast.
What I'm trying to do is provide the best possible chronology for Barbara's lake core sediments.
The cleaned and dried samples, once weighed and sealed under vacuum, are combusted. A reaction with copper oxide forms carbon dioxide. Hydrogen is added to these samples, then heated, turning the CO2 into pure carbon. That goes into the electron mass spectrometer, 50,000 volts is applied, a cesium oven ionizes the carbon and turns it into charged particles, which move through the system. At the end of the process, they're left with a radioactive component of carbon. The measurement of that gives the age of the sample. Queens is also where much of the pollen analysis is done. Chris Hunt has worked extensively in Southeast Asia and brings his vast experience to the research. He and his team subsample the material in the laboratory.
Basically, from each level of a core, we would take pollen in the region of 400 or 500 grains, count them, identify them, work out which plants they came from, and so it gives us quite a good signature for things like rainfall and temperature.
Back in Stockholm, the PhD students have started publishing the results. Overall, the work covers nearly 50,000 years of the monsoon's history. Mu is working on the last 11,000 years.
What I'm doing now is I use lake sediment as a paleoclimate archive to tell us about the climate in the past and monsoon variability in Thailand.
She's added a whole series of new chemical tools to the analyses of the sediments, and so in doing so she's actually been able to understand the dynamics of this very, very large lake wetland system.
Sediment is constantly deposited on the lake bottom. During the weak monsoon conditions, the lake level reduces, eventually drying out, which is when peat forms. During strong summer monsoons, the levels rise again and the sediments form. Nutt is concentrating on the last glacial maximum, 20 to 21,000 years ago, and the period immediately before that.
I have synthesized the paleoclimate record from the Asian monsoon region. For the time interval in the northern hemisphere was covered by the last ice sheet.
So he compiled published data sets and he compared them with a climate model output or climate model output data to see how well they fit together. He can see that not all regions were very dry during the last glacial maximum, but we have certain areas that were dry, but other areas that show much wetter conditions.
The work has already affected our understanding of the monsoon on global climate patterns. In the coming years, the level of knowledge looks set to grow still further.
I think we've got a fair ways to go because, as I said, it's really a very dynamic region with these winds that are coming from all sorts of directions. Although we may have a big picture understanding of some of the dynamics, we want to sort of refine our temporal understanding of how do things change on shorter time intervals.
In a 2-year time frame, I would like to very much to move, for example, to Indonesia. I would also like to move further to the west into Burma, Myanmar if possible, because then we could probably get a better link towards India and studies that have been made in India. To the question, what influences what and what governs what, we haven't come there yet. But I hope that we would be able, with our records, to solve that in the near future also.